seasonality. That is, that is like repeating short-term cycle in data. For example, more ice cream sales are done in summer and holiday shopping spikes in December because, as you already know, in summer everybody craves ice cream and holiday shopping spikes in December because of the winter vacation. The third component for this is noise, that is residuals. So basically they are the random variation in the data that cannot be explained by trend or seasonality. So they are basically occur due to unpredictable events, that is like for example that would be weather, politics and strikes. So in seasonality, so it basically refers to the fluctuation that occurs at regular intervals, typically linked to calendar seasons, months, days, or weekdays. So basically, this is used to plot a graph. Oh, wait a second. So yes, basically seasonality, it refers to the fluctuation that occurs at regular intervals. So it is used to plot a graph. As the topic for today is like time series, so we'll be seeing the forecasting and the difference as I have described. The time series consists of trends, seasonality, and noises. So we basically plot a graph against it. And as for noise, they are the random variation in data that cannot be explained by trend or seasonality, and it is often due to unpredictable events that would be weather, politics, or strikes. This will be the code that we'll be using. So this is an example for noise. So basically, after combining all the three components of time series, that's how the forecasting is done. So basically, why do we forecast? Can somebody tell me why do we forecast?
for accurate
Sorry?
result or
Okay. Any more answers? So basically, forecasting means that we are using past observation to predict future values. And forecasting also product demands to manage inventory. And it also means, like, for example, we can predict the electricity usage for grid planning or estimating financial risks and returns, and also anticipating disease outbreaks, that would be COVID-19 modeling. So basically, the challenges that are faced in forecastings are like non-stationarity, like as the data changes over time, sudden drifts or sudden jumps, it happens. So it can happen anytime. And the second challenge would be the missing data. That would be like times with no observations. Third challenge would be outliers, extreme values that skew forecasts. Fourth would be seasonal patterns, that would be like varying in intensity or timing. Lastly, last challenge would be that lags effects. So the events influencing future values with a delay. So now we will move to the Facebook Prophet. So basically, what is a Prophet? Prophet is an open source forecasting tool created by Facebook, now Meta. It is designed to make the time series forecasting accessible to non-expert and robust for business uses. So Prophet uses an adaptive model of the form of this formula, and these are the terminologies that are used for GT, like the trend. As I have explained, the components of time series. A trend is also a non-periodic change in the value of time series. So ST would be seasonality, that is periodic changes, daily, weekly, or yearly. HT would be holidays, that effects of events like Christmas, Black Friday, etc. ET would be noise, error, and random variability not explained by the model. Once again, see this formula. We will be using this formula for the Prophet. And once again, go through these terminologies of the abbreviations used in the formula. So basically, why use Prophet? Why do we use Prophet? So we are using Prophet because it handles trend and seasonality and holidays, and it also works with irregular or missing data. It also automatically detects change points in trends, and it is great for daily, weekly, and yearly time series data. That would be seasonality, so it works with it. So where basically we are using Prophet for forecasting daily or monthly business data with multiple seasonal patterns, but it is not ideal for very short time series or data with no seasonality or trend, and also not suitable with high frequency data, that would be, for example, seconds or milliseconds. So it handles multiple frequencies, and it also automatically adjusts for missing data points or irregular sampling, and it is robust to outliers. And Prophet uses a piecewise linear or logistic growth models that can handle spikes or dips without breaking. And you can add custom chain points or let Prophet find them. So there is automatic change point detection as well, because change points are the moments in the time series when the growth rate suddenly changes. For example, a sudden drop in sales due to COVID-19, and a sharp increase after launching a new product. So Prophet detects change points automatically, but you can also provide on your own. So this is the So basically, in this, we will be visualizing the change points, and then hence it will be forecasting using the profit. So as I have told that it detects change points automatically, but we can also provide on our own as well in this. So for step is like first we need to install the profit using pip. Then the second one is like as profit expects two columns. So DS would be date stamp and Y would be the value to forecast. So this is the raw data that we will be using airline passengers. So as I have told in the previous slides, it would expect two columns. DS would be the date time, and Y would be the value to forecast. And as you can see, so we need to predict the time series. So hence we are using this. So third step would be to fit the model. Then the fourth step would be to create the data frame. So step 5 would be to make predictions, that is forecast. And step 6 would be to plot the graph, that would be the forecast with profit. And step 7 would be to view the components, that would be trend, yearly seasonality, weekly seasonality if applicable, and holidays if provided. Like this is all done by using the formula that is shared. Basically, this is the formula that will be used. So now we will proceed to ARIMA. So basically, ARIMA stands for Autoregressive Integrated Moving Average, a powerful and classical statistical model used for time series forecasting when the data shows evidence of non-stationarity. So autoregressions means that it uses past values of the time series. Integration, that is differencing to make the series stationary. Moving average, that is MA, it uses past forecast errors to predict next value. So basically autoregressive, that model predicts a value on using its own previous value. So as you can see that, so for autoregression, P is used, that uses past values of the time series, and I stands for integration. D is used for this because this is the differencing to make the series stationary. Moving average, Q is used because it uses past forecast errors to predict the next value. So basically, the model predicts a value using its own previous value. So this is the formula that is used by autoregressive. And as for integrated, it involves differencing the time series data to make it stationary. That would mean constant mean and variance. So first order difference is being found. So if the series is still not stationary, applying differencing again, then the second order would be used. So this is calculated by using this formula. So the parameter D is the number of differences needed to remove the trend. So now moving forward to moving average, that really focuses on using past forecast errors in a regression model. So in this, it means that it uses the last two forecast errors to make the prediction. So this is the formula that will be used. So the model notation for ARIMA is P for number of lag or observations, that would be autoregressive. D would be integrations, number of times data is difference. Q would be moving average, and that is size of moving average window. So limitations of ARIMA is that it only works on univariate data. So it also assumes linearity and it needs stationarity. So, and it is also not so great with complex data. So basically why we compare models, because different models makes different assumptions. ARIMA assumes linearity and stationarity, but Prophet is flexible with trend plus seasonality plus holidays. And naive model serves as baselines, and machine learning models like random forest, XGBoost can learn nonlinear patterns. So basically, univariate data involves observation of a single variable. It means that the data set that has only one feature or one column or only one variable that is being analyzed or studies. Like example for temperature. So temperature is only a one variable that will be used, right? So suppose if the temperature is 31 degrees Celsius, then the data will be taken for this instance will be 31 degree itself. So it cannot change. So basically univariate data refers to the data set that has only one feature or one column or one variable being analyzed or studied at that instance. So basically, mean absolute error, that is absolute average absolute difference between predicted and actual values. RMC, that would be root mean squared error, that is square root of average squared errors. And MIP is mean absolute percentage error, and this is the formula that is used for it. Okay, now we will be proceeding to the code. So in this, we will be using the ARIMA technique. So we are using the data sets for airline passengers, and the data is for airline passengers from 1949 to 1960. So the split will be 1959 and 1960. The figure is not visible to you in this. Is it showing or not?
Yes, ma'am.
It is showing. The figure is showing.
Yeah.
The chart is visible to you.
Yes, yes.
Okay. Okay. Then that is fine then. So basically, in this, clear seasonality is being shown. That is regular up and down trends with each year. And the strong upward trend is like overall growth in passengers number of over time. So data is ideal for
Ma'am,
time
figure
series.
not showing. Only code screen is visible.
So that's what I asked you. Wait, I will just share it once again. Now it is visible, right? I think in visual code it is not showing. So once again I'll start. So basically, the plot that is being displayed, it shows the clear seasonality. That means the regular up and down trends within each year. And the data that is being showed in front of you is from 1949 to 1960. So the strong upward trend indicates the overall growth in passengers numbers over times, and the data is ideal for time series forecasting. And as you can see, the MSC, wait, that is mean squared error, is 3049. That means on average your model's predictions deviate from the actual numbers by about 55 passengers in terms of RMSC. So basically this is a moderate error, not perfect but quite reasonable without heavy tuning. So as you can see, the blue line, that is the training data from 1949 to 1959. The green line is the actual test data from 1960, and the red dashed line is the forecasted values for 1960. So basically, the red forecast line shows the green actual values fairly well. So it captures the trend and seasonal movement through, possibly with some lag or smoothing. And this also means that the auto regression has used the value p that is equal to 2, because model uses the past two values to predict the next, and for integration, that is d is equal to 1, because this series was differenced once to make stationary, and m is q is equal to 2, because the moving average is, like, as you already know that I have stated, auto regression is 2. So the model has used the past two error terms in prediction. So basically the summary of this is, like, the model they have used is ARIMA, and the auto regression they have used is 2. Integration, that is d, that is has been used as 1. The moving average has used as 2, and the test data period is 12 months, that is held out for prediction, and the mean square error also came to 3049. So that is like a moderate error, and the forecast shape is seasonal trend, which predicts value match seasonality trend of actual. So this is the mean squared error that we have got. I hope the screen is visible, right? Everybody is able to see.
Yes, ma'am.
Vastavi, are you able to see the output? At first, I did ask about the figure itself, and but somebody told that the figure is visible. That's why I was doing in VS Code. There is some issue that it is popping in a different window and it is not being able to share. So once again, the model notation for this is like auto regression, that is P, that has used the value 2, and integration, that is D, is equal to 1, because the series was differenced once to make it stationary. So first order is used, and the moving average, that is 2, because the model uses the past two error terms in prediction. So the model notation is P is equal to 2, I is equal to 1, and Q is equal to 2. So as I have already explained the model notations for ARIMA, that is P, I, and Q. So once again, the blue line is for training data from 1949 to 1959, and the green line is for actual test data, that is 1960, and rest red dash line is for forecasted value for 1960 using ARIMA. So the model notation is 212, as I've already explained about it. So this is it for ARIMA. Please go through the code once. Then we will move to other example. So okay, I hope everybody went through the code. So this was the model notation I was talking about. So please go through this. So P stands for auto regression, D stands for integration, and Q stands for moving average, that is 2 because they have used the past two data sets. So okay, now we will move to the other example. So in this, we will be using the profit. So for this also, we are going to use airline passengers data set only. So as I've stated that DA stands for stands for date stamp, and Y is the value to forecast that has been used. So data set is used till 1960.
So basically, they want to forecast future, and then we will be calculating mean squared error as well. And the forecast is as follows. So basically, it indicates the model using profit, and it is also representing the x-axis is representing the date. That means the years from 1949 to 1961, and y-axis is representing the passengers, the number of passengers in thousands. And the data points and the lines are like basically the black dots. Those are the observed data points. That means the historical passenger counts, the black dots. And dark blue line is the forecasted trend by profit, and it predicts the number of passengers over time. And the shaded blue area is the confidence interval, that is usually 95% around the forecast. It basically indicates the range in which profit believes the true values are likely to lie. And wider intervals suggest that high uncertainty in the forecast. So once again, I will explain the data points and lines.
The black dots are the actual observed data points that are real historical passenger counts. The dark blue line is the forecasted trend by profit. It also shows the predicted number of passengers over time. And the shaded blue area, this is basically the confidence interval, that is usually 95% around the forecast. It indicates in which profit believes the true values are likely to lie. And the wider interval suggests higher uncertainty in the forecast. So the model performance, as you can see, the root, like the mean squared error is 1854.84, as you can see here. So basically, MAC measures the average of squares of errors, that means different between predicted and actual values. So basically, lower value indicates better accuracy. But in this case, MSC of 1858 sorry 1854.84 suggests some prediction errors, but the given scale of data, that is like passenger numbers in hundreds, that is relatively acceptable. So basically, profit captures this seasonal component very well, and there is an annual pattern, that means that the peaks around mid-year, that means the summer travel, and there are some dips near year end. So, like for trend, overall increasing trend in air travel from 1949 to 1960. So, profit accurately follows this upward trend. And as for the prediction range, the model was trained on earlier data. So it starts forecasting at some point, because you can notice where the dark blue line starts to diverge from black dots. So even though the profit follows the overall shape well, some values that are black dots fall outside the confidence band, indicating model limitation, or like you can say that. Please go through the code and the output once. I will just please go through the code first, then I will show the output once again and I'll explain it once again. So again, I will explain once again. So as for the black dots, these are the actual observed data points. And for the dark blue line, this is the forecasted trend by the prophet. And it shows the predicted number of passengers over the time. And the shaded blue area, this is the confidence interval that is 95% around the forecast. So it indicates the range in which prophet believes the true values are likely to lie. And the wider intervals suggest higher uncertainty in the forecast. So as for the mean squared error, that is 1854.84. So it is relatively acceptable because the given scale of data is in 100. So insights from the plot, that is like seasonality is predicted from a very clear annual pattern. Prophet captures this seasonal component very well, and the trend, as you can see, that overall increasing trend in air travel from 1949 to 1960 has been captured in a well mannered. And for Prophet, accurately follows this upward trend. And as for the prediction range, the model was trained on earlier data, so it starts forecasting at some point. So you can notice where the dark blue line starts to diverge from black dots. So, but as you can see that the prophet follows the overall shape very well, but some values that black dots fall outside the confidence band, so it indicates model limitations or possible anomalies. So I hope this is clear. Then now we will get to other example of prophet. So in this prophet model, we are using milk production synthetic data and normal milk production data. So basically, the milk production forecast that would be done by Prophet model, and you can see the data has been taken from 2010 to 2020. So it is basically applied to monthly milk production data. In axis that you can see that the range from 2010 to 2022, like 20 actually, like to be very precise, it has been taken because it represents the timeline of monthly milk production. So in y axis, milk production in pounds that has been taken, so that's why the amount of milk produced in pounds that has been taken in y axis. So basically in this, so this, so the black dots that represent the actual absorbed monthly production values. So from 2010 to 2020, most of these values are available. And the blue line, that is forecasted. So this is the forecasted value of milk production from profit. And the model captures both seasonality and the long term trend. And as you can see, the shaded blue area that shows confidence interval that is typically 95% around the prediction. So it tells how confident prophet is in its predictions. So the narrow band means that high confidence, wider band means more uncertainty. So as you can see, wait a second. So as you can see, the forecasted table that is there. So the first one, that is 1st January 2021, that the profit predicted is like for milk, that is nearby equal to 6367. And that means that it is like 6367 lbs, that is pounds. So the confidence range is between 6270 and 6463. As you can see, this is the lower and the upper. So this is the confidence range. So basically what we understand from this is that the seasonality, the clear annual seasonality in milk production, that means the peaks and dips like repeat consistently in each year. And the profit models this with periodic functions internally. And as per for the trend, the overall trend, that is upward only, because milk production is increasing gradually over the time. And as per for the forecasting period, that is like profit uses past data. The data set that has been used is from 2010 to 2020 to predict future values for 2021 and 22. So as you can notice that the confidence interval becomes slightly wider as we move into the future, indicating uncertainty. So wider curve means like wider curve or band means more uncertainty, and if the narrow band is present, then high confidence is there. So basically for the model accuracy, the forecasted line, that is blue, fits the actual values, that means the black dots, very closely throughout the historical period. So this suggests that the prophet has done a good job in modeling both trend and seasonality. And as we already know that no forecast is ever 100% certain, because profit models use uncertainty using past error patterns and the variability in trend plus seasonality. So wider intervals imply more like uncertainty, that means long term future or highly volatile data. So but in this case the interval is only about plus 95 lives wide on each side. This indicates high confidence in this particular prediction. I will explain once again about this. So basically, the black dots, so they represent the actual absorbed monthly milk production values. And from 2010 to 2020, most of the values are available, so they are being forecasted. So the blue line, that is forecasted. Why that? So this is the forecasted value of milk production from profit, and this model captures both the seasonality and long-term trend. And the shaded blue area, that is uncertainty interval, this typically shows the confidence interval, that is 90% around the, sorry, 95% around the prediction, and it is how confident the profit in is in its prediction. So basically, when the narrow band is present, then high confidence is there, and if the wider band is present, then more uncertainty is there. As you can see in the first one, the date stamp for 1st January 2021. So the predicted milk production is 6367, and the confidence range is, the lower confidence range is 6270.73, and the upper confidence range is 6463 lbs. So based on the observations, as we already know that no forecast is 100% certain. So basically, profit models uncertainty using past error patterns and the variable in trend plus seasonality. So they use it both. So like overall, by the plot, what we got to know is that seasonality, it is providing a clear annual seasonality in milk production. So the peaks and dips repeat consistently each year, and the profit models this with periodic functions internally. As for the trend, overall upper trend is there, so the milk production is increasing gradually over time. And as for the forecasting period, Prophet uses past data, that is from 2010 to 2020, to predict future values for 2021 to 2022. And you also notice that the confidence interval becomes slightly wider as we move into the future. That indicates increasing uncertainty. So, but as for the model accuracy, the forecasted line blue fits the actual values. Those are the black dots that are actual values. So they fit the actual values very closely. So throughout the historical period. So this suggests the prophet has done a good job in modeling both trend and seasonality. Please go through the output, then we will end the session now. So it's already 9:32. So please go through once. Okay, then we will end the session now. And please start doing your project. The review will be soon for the first project. So I hope you guys are working on that. All right, then we'll be ending the session, and please revise the topics